Hi, Mr. Travis. Congratulations on the incredible journey from idea to invention to product launch. Wishing you great success as you take this innovation to market, with support and respect from Tony, Rocket 30, and Diverse Ventures. The audio presentation will have a step-by-step blueprint on how to take your idea from concept to completion.
Welcome to this very focused deep dive. This is really something quite unique, Mr. Travis. Normally, we'd be looking at sources for a broader audience, but today, well, we've custom-tailored an entire strategic roadmap, a full blueprint, really, for your specific vision.
That's exactly it. This deep dive represents a significant commitment from Rocket 30. It's designed specifically to take your concept for the automotive assistive device and map out how to turn it into a successful, profitable business.
Yeah, and what we're presenting here, Mr. Travis, it isn't just, a market summary or some preliminary thought.
No, not at all. Think of this as your integrated operations manual. We've systematically broken down the whole journey for this really crucial product. It addresses fundamental mobility challenges, right? Getting in and out of cars. And we structured it as an actionable four-phase plan.
So let's be absolutely clear on the mandate here, Mr. Travis. This is the blueprint to take an idea from concept to production and all the way through to an exit strategy, a complete start-to-finish roadmap.
Right, a full roadmap.
And, just to underscore how important this is, we really have to acknowledge that this comprehensive guide, it was personally requested by Tony, the CEO of Rocket 30, specifically for you in your endeavor.
He absolutely did. Tony made a special exception here, authorizing this complete custom presentation exclusively for you, Mr. Travis. Honestly, this level of personalized detail, the resource allocation, it's extremely rare.
It really is.
It shows the confidence Rocket 30 has, not just in the product idea itself. I mean, a device offering crucial stability and safety, that's huge, but also in your ability, Mr. Travis, to execute this vision.
So we're going to guide you through these four phases. We'll start right now, laying the foundation, securing the core of your idea, which really is built on solving a very real, very critical problem.
Okay, phase one, laying the groundwork.
First things first, let's unpack the sheer urgency of the problem you're tackling, Mr. Travis. This isn't just a nice-to-have gadget, is it?
Not even close. It's really a critical health and safety intervention. The data we looked at underscores this.
Right.
There's a pretty staggering statistic.
Yeah.
Roughly 37,000 Americans over 65 suffer serious injuries every single year just from getting in or out of a car.
37,000, that's a lot of people, just from that simple action.
It's huge. And these injuries, they're mostly linked to things like limited hip rotation, maybe reduced core strength, or just poor balance, common issues,
Right.
Now, if you frame that as a market opportunity, well, the picture gets even bigger. The senior population is massive. We're looking at about 58 million people age 65 plus in the U.S., projected for 2025.
58 million, and within that group, there's a key demographic fact, isn't there, about mobility limitations?
Yes, exactly. Within that huge pool, roughly 40% of seniors report having some form of disability or limited mobility. That's your total addressable market. And it's not just growing. It's a market that's actively looking for safe, dignified ways to keep their independence.
So the need is definitely there, which brings us to the first official step, Decision Gate 1.
Right. Decision Gate 1. This is all about rigorously defining user needs and really committing to inclusive design because the stakes are so high.
Okay, and how long does that initial research take? Is it costly?
It's relatively quick, actually. We estimate maybe 4 to 6 weeks for this initial phase, and the cost is minimal, really, compared to its importance. But you absolutely cannot skip it.
So this step, it's about moving past just saying, it needs to be easy to use, right? It needs more definition.
Way more definition. Decision Gate 1 demands tangible, measurable success metrics, documented right up front. So, for example, the device must support a dynamic load of, let's say, X pounds, probably 250 pounds minimum.
Right.
It has to attach securely in under, say, Y seconds. It needs to weigh less than Z ounces, so it's portable. And crucially, you need to demonstrate compatibility across a specified percentage of common vehicle types, sedans, SUVs, maybe even some trucks.
Needs to work everywhere.
And the guiding principle here, something people often miss, is that designing for older adults is inclusive design. It really is.
How so?
Well, think about it. If you design something that's simple, flexible, and robust enough for someone with, say, severe arthritis or very limited mobility, you've automatically made a better, more user-friendly product for everyone.
That makes sense. Can you give some practical examples? For this specific device, what does inclusive design look like in the physical build?
Sure. So the handle shape, right, needs careful ergonomic thought. A thin, smooth handle that's pretty useless for someone with arthritic hands, limited grip strength.
Right.
You might need a wider diameter, maybe add some texture, a specific contour, perhaps even angle it slightly to match natural wrist positions when someone's transferring their weight.
Okay. What else?
High contrast coloring is essential. Think maybe a bright yellow or red tip against a darker base. Helps users with failing eyesight locate it easily. And the operating mechanism, it has to be simple, require minimal force, maybe a single large button or lever, definitely not a tiny fiddly switch.
Got it. So who should you get feedback from in this phase? Just potential buyers.
Buyers, yes, but also physical therapists,
Mm-hmm.
occupational specialists. These are the people who see the exact biomechanical strains during car transfers every single day. Their input is gold.
Okay. So once you've really nailed down those user requirements, what's next? Decision gate 2.
Exactly. You pivot immediately to the competitive landscape and, crucially, freedom to operate, FTO. This is decision gate 2. Think of it as your non-negotiable legal insurance policy, Mr. Travis.
Legal insurance. Okay. So before committing serious money to engineering.
Absolutely before. You must analyze and benchmark what's already out there. We know the field includes simple mechanical aids, right? Like the handy bar, which hooks onto the car's door striker pin.
I've seen those.
And then at the high end, you have more complex installed systems, like those turny rotating car seats.
Yeah. So you need to analyze their function, price,
And their patents.
their patents critically. This leads straight into the FTO analysis, freedom to operate. We know, for instance, there are existing U.S. patents covering specific mechanics, like those removable support handles that slot into the door latch striker. Okay, so how do you do this FTO check?
Well, an initial screening is pretty simple. You can use free tools, USPTO database, Google Patents, just to get a basic landscape view. But honestly, Mr. Travis, for a product you intend to manufacture and sell widely, we strongly, strongly recommend engaging a patent attorney for a professional FTO opinion.
Spending, say, several $1,000s on an FTO opinion, that seems like a big cost before you even have a finished prototype. Can't you just whisk it? Especially if you're starting lean.
That upfront cost maybe $3,000, maybe up to $10,000. It's honestly the cheapest insurance you will ever buy against potentially catastrophic future legal trouble.
Catastrophic how?
Imagine you scale up production, you're shipping units, then boom, you get a cease and desist letter. Or worse, a lawsuit for patent infringement. The cost to defend yourself, maybe redesign the whole product, scrap all your inventory, that could easily hit 6 figures, maybe more. An FTO helps prevent that nightmare scenario. It proactively checks if your specific device concept is clear of infringement risk.
Okay, that makes sense. So decision gate 2 requires confirmation you're legally distinct. What if the analysis finds a patent that looks, well, kind of close?
Good question. The immediate strategy then is to design around that existing IP. It's a bit of an art form, really.
Designing around.
Yeah. So let's say a competitor has a patent on a support device that attaches rigidly to that striker pin. Okay, maybe you explore attaching to the B-pillar handle instead. Or maybe you develop a floor-mounted friction mechanism. If their patent covers the specific spring release, maybe you shift to a magnetic catch or a cam-based mechanism.
So you adjust the mechanics?
You adjust the mechanics, the material, the size, the location, the function, just enough so your invention falls clearly outside the legal scope of those existing patent claims. The goal isn't just to be slightly different, it has to be legally distinct.
Got it. Legally distinct.
Yeah.
So once the FTO is clear, or you've figured out your design around strategy, the clock starts ticking on protecting your own idea, right? It's decision gate 4.
Right. Securing your innovation. Intellectual property strategy. Decision gate 4. And timing here is absolutely critical, Mr. Travis.
How so?
You need to file a provisional patent application, a PPA, pretty much right away, as soon as your concept is defined enough.
Okay, a PPA, what does that involve? Is it expensive?
It's actually a relatively low-cost, fast way to get started. Filing it establishes your official priority date for 12 months, and it lets you legally use that powerful phrase, patent pending. The actual USPTO filing fee for what they call a micro-entity, like an independent inventor, is minimal, often under $70.
$70, that's it.
Well, that's the government fee. But, and this is important, having an attorney professionally prepare it, making sure the description and drawings are solid enough to actually support your future claims that usually run somewhere between $2,000 and $5,000. It's worth the investment to do it right.
Okay. So that PPA buys you 12 months. That's your lifeline, Mr. Travis. You use that year to refine the design, test prototypes, gather that crucial user data, maybe even approach potential investors.
Yeah.
All while having that patent pending buffer.
Exactly. But after that 12 months is up, you must transition to the non-provisional or utility patent. This is the real deal, the one that can actually be granted and enforced.
And this is where the costs jump.
This is where the costs jump significantly, yes. It's the heavy lifting stage. Attorney fees typically range from $5,000 up to maybe $15,000 or even more. They have to meticulously draft the claims, those are the legal boundaries of your invention, and then manage the whole prosecution process with the patent office.
Prosecution process. How long does that take?
Yeah, the back and forth with the patent examiner, it's slow. You should expect it to take 2 years, maybe even longer, before the patent is actually issued or granted.
Wow, 2 years. Okay. Now, thinking bigger picture, longer term, those high-value pathways we'll talk about later. What about protecting this internationally? If you think about selling in Canada or Europe, or even just worry about factories overseas copying it.
Great point. That's where the Patent Cooperation Treaty, or PCT route, comes in. If you file a PCT application within that original 12-month PPA window, it basically keeps your global options open for 30 months from your initial filing date.
30 months. So it buys you more time.
It buys you significant time, yes.
Right.
Which is strategic because filing internationally is incredibly expensive. Filing in individual countries, dealing with translations, local patent attorneys, it can easily cost $5,000 or more per country. The PCT effectively lets you defer that massive cost for an extra 18 months. Gives you time to prove the market, secure funding, then decide which specific countries are worth the investment.
Okay, that makes a lot of sense. So the immediate action for you, Mr. Travis, seems pretty clear based on this.
Absolutely. File the U.S. provisional now, lock in that date, then budget and plan strategically for filing the full utility patent and possibly the PCT application right around that 12-month mark.
Right. This strategy ensures you maximize your leverage with potential partners down the road and protect your core concept while you move into what sounds like the most technically challenging phase, the actual design and validation.
Okay, phase 2. This is where we go from, paper protection to actual physical proof. The first step here is preliminary design and prototyping. This leads us to decision gate 3.
And this phase really demands adopting that fail-fast approach, doesn't it?
Absolutely. Fail fast, fail cheap. Initially, you're looking at what we call low-fidelity prototypes. Think really simple 3D printed handle shapes, maybe mock-ups using basic, inexpensive stuff like foam or wood.
Just to get a feel for it.
Exactly. The absolute goal here is rapid feedback on the basics. Functionality, fit, how it feels in the user's grip. Catching a flaw, like realizing, oh, this handle angle totally interferes with the car's door panel, is just orders of magnitude cheaper than finding that out after you've dropped $20,000 on steel tooling for mass production.
Right. So lots of iteration based on feedback.
Continuous iteration is essential. If early testers struggle with the release mechanism, you change it. If users with limited vision keep missing the attachment point, maybe you integrate a tactile guide or use those high-contrast graphics we talked about.
And the timeline and cost for this early prototyping.
We estimate this stage takes about 2 to 3 months. Cost-wise, you're looking at maybe several $100s in materials, plus potentially $5,000 or more if you need help from a freelance CAD specialist to get those initial digital models refined.
Okay. And decision gate 3 requires what? Just having a prototype.
It requires proof of concept, confirmation that your initial prototype actually addresses the fundamental user need you identified, and that you've resolved any major show-such-up usability issues found in early testing.
Got it. So once that core concept is validated, we move into the more serious engineering, decision gate 5.
Exactly. Detailed engineering and design lock. This culminates in decision gate 5. And yeah, this is the transition to highly professional, high-fidelity design work.
High fidelity meaning?
Meaning using advanced engineering tools. It's indispensable here. You have to move beyond simple sketches and produce really detailed 3D CAD models. Computer-aided design. And critically, you must use finite element analysis, or FEA.
Okay, FEA. For our listeners, Mr. Travis included, who might not be engineers, can you break down what FEA is and why it's absolutely non-negotiable for a safety device like this?
Sure. FEA is basically a powerful computer simulation tool. Instead of physically building and breaking dozens of expensive prototypes,
Right.
you use software to digitally apply real-world stresses, forces, heat, vibration, whatever is relevant, right onto the 3D model. It helps you visualize exactly where the weak points might be, where stress concentrates, how the material might bend or ultimately fail under load.
So it predicts failure without breaking things.
Precisely. And since this is an assistive device, something supporting human weight during a potentially unstable movement,
Yeah.
you absolutely must engineer in a substantial safety margin. We strongly recommend a minimum of 2 times the intended maximum load.
2 times. So if it needs to support a 250-pound person.
The FEA simulation must demonstrate it can handle 500, maybe even 600 pounds without any permanent deformation or failure. Doing this simulation saves massive amounts of time and money compared to just physical brake testing.
Okay. And running parallel to that FEA simulation is material selection, right? Finding that sweet spot between strength, weight, and durability. What materials are usually considered, Mr. Travis?
Good question. For the core structure, you're typically looking at high-strength but lightweight options. Aircraft-grade aluminum alloys like 6061T6 are very common. They're light, strong, naturally resist corrosion.
Okay. Aluminum. What else?
Alternatively, you might consider an injection-molded reinforced plastic, something like glass-filled nylon. Now, aluminum offers that inherent strength and maybe a more premium feel, but specialized reinforced plastics can sometimes offer better resistance to extreme temperature fluctuations inside a car, and they can be significantly cheaper to manufacture at scale once you've paid for the initial mold tooling.
Right. The tooling cost for plastic is higher up front.
Exactly. But crucially, Mr. Travis, whatever material you choose, it must withstand the extreme temperatures you find inside a car cabin. We're talking ambient temps that can soar to 180 degrees Fahrenheit easily in direct summer sun.
Wow, yeah.
And it must meet essential flammability standards. We'll get more into that.
So before you can officially lock the design, you need more prototypes, higher fidelity ones.
Yes, you need multiple rounds of high-fidelity beta prototypes. These might be made using CNC machining from a solid block of the final metal, or perhaps short-run injection molding using the actual final plastic. These let you test the real thing.
And Decision Gate 5 is when you're happy with those.
Decision Gate 5 confirms that the final detailed design meets all the performance requirements, weight, load specs from the FEA, and that it's fully optimized for however you plan to manufacture it. Design locked.
Okay. Design locked. Now the conversation shifts immediately to safety, which you mentioned. This leads to Decision Gate 6, human factors and safety compliance.
Paramount. Absolutely paramount for Decision Gate 6. The safety mandate here is really twofold. You've got functional safety, and you've got regulatory compliance.
Let's break down functional safety first. You said the device can't interfere with the car's normal operation. What are the key risks there? It seems simple enough.
The risks can be subtle but critical. First, the door latch itself. If your device interacts with the striker pin, like the handy bar does, you have to be 100% certain it cannot prevent the door from securely latching closed when the device isn't being used, or somehow compromise the latch's strength.
Okay, latch integrity. What else?
Second, you must ensure the device cannot, under any circumstances, impede any vehicle safety systems. The big one here is side curtain airbags. They're often integrated into the B-pillar, right near where a secondary handle might attach. You need exhaustive research into the geometry of typical car interiors to ensure zero obstruction if an airbag deploys.
Right. That's critical. Okay, now regulatory compliance. You mentioned it's not FDA regulated, but there are automotive standards. Which ones absolutely must be met?
The big one, the absolute must-pass, is FMVSS 302. That's the Federal Motor Vehicle Safety Standard. It governs the flammability of interior materials used in vehicles.
FMVSS 302, okay.
This isn't optional, Mr. Travis. It's mandated by law for products intended for use inside a vehicle cabin. The requirement is strict. Your chosen materials must have a burn rate that does not exceed 102 millimeters per minute when tested under specific conditions.
So if you use plastic, it needs additives.
Correct. If you select a plastic, it almost certainly needs fire retardant additives mixed in to ensure compliance. This is a non-negotiable pass-fail test you'll need certified results for.
Got it. Beyond fire safety, let's circle back to load testing. You mentioned the 2x or 3x static load test earlier, but you also brought up a 20-gram crash force testing benchmark. Why simulate a car crash for an aftermarket handle? That seems extreme.
It might seem extreme, but it's necessary for credibility, Mr. Travis, especially if you ever want to approach those high-value OEM partners we'll discuss in Phase 4.
Ah, okay. Credibility for the automakers.
Exactly. Passing a static load test, holding 600 pounds for 60 seconds proves the product won't break under normal intended use. That's basic function. Passing a dynamic 20-grain crash test, which simulates the intense forces experienced in a moderate to severe collision, proves that your device itself won't break apart and become a dangerous projectile inside the cabin during an accident.
I see. It shows it won't add new danger in a crash.
Precisely. It demonstrates true automotive-grade durability and liability awareness. It signals to the highly risk-averse auto industry that you understand their rigorous safety standards. It's a huge differentiator.
Makes sense. So Decision Gate 6 also requires final checks on human factors, right? Like grip strength, simplicity.
Yes. Final validation. The handle diameter suits limited grip strength. Operation is dead simple. Decision Gate 6 requires a formal safety and compliance sign-off document, confirming all load, flammability, and functional interference risks have been identified and fully mitigated through design and testing.
Okay. Safety signed off. What's the next step? Feels like a dress rehearsal.
That's a great way to put it. Next is pilot production and validation testing, culminating in Decision Gate 7. This is the final check before hitting the big go button on mass production.
Pilot production.
Yeah.
So making a small batch, like 10 units. 100 units. Why is that small run so crucial before committing to thousands?
Because this pilot build validates not just the product anymore, but the entire manufacturing process you set up with your chosen partner. Did the factory interpret the CAD files correctly? Are there any tricky assembly steps that introduce errors or inconsistencies?
Testing the factory too.
Exactly. And these pilot units, maybe 50 or 100 of them, they undergo hyper-rigorous testing, functional testing across a wide range of car models. You need to confirm broad compatibility. Does it fit well in a small sedan, a big SUV, maybe even a pickup truck? Because door geometry varies dramatically between vehicles.
Right. And what about wear and tear? How do you test for long-term use?
Durability testing. You have to simulate years of use in just weeks or months. This means cycle testing. Setting up a rig to automatically attach and detach the device maybe 5,000 times, maybe 10,000 times, simulating 5 to 10 years of real-world wear.
Okay. And environmental factors.
Definitely. Environmental testing is key. Subjecting units to extreme heat cycles, extreme cold cycles, checking for corrosion resistance, maybe with salt spray tests, especially if metal parts are exposed. You need to ensure the device won't degrade or fail when it's just left sitting in a car cabin through blazing summers and freezing winters.
Makes sense. And the final piece, the human element, the beta trial.
The beta trial is your crucial real-world check. You take those 50 or 100 pilot units and get them into the hands of a controlled group of actual end users. Senior centers are great for this. Rehabilitation clinics, maybe even home health agencies.
And what are you looking for from them?
Long-term feedback. How does it really perform after 6 months of daily use? Are the instructions clear enough? Does the device inadvertently scratch the car's interior paint? Is it still easy to use? This real-world durability and usability feedback is absolutely invaluable before you scale.
Okay. So this whole pilot program takes how long? Costs how much?
The pilot program usually takes about 1 to 3 months, depending on the testing involved. Budget-wise, you should probably allocate somewhere between $10,000 and $30,000. That covers potential fees for independent test labs, plus the cost of producing those pilot parts.
And Decision Gate 7 is the green light.
Decision Gate 7 is the final confirmation. It means the pilot units meet all the defined quality standards, the manufacturing process is stable, and critically, that external beta feedback confirms the product truly and effectively solves the problem for the target users. You're ready to scale. All right, Phase 3, scaling up. With a proven, safe, and hopefully patent-pending design, we shift focus squarely onto mass production. This kicks off with vetting manufacturing partners, leading to Decision Gate 8.
And the first big decision here, Mr. Travis, is that classic one. Domestic versus overseas production, right?
That's the foundational choice. Let's unpack the trade-offs.
Okay. Domestic pros and cons.
Domestic manufacturing, say here in the US, offers huge advantages in communication. No language barriers, same time zones generally, makes collaboration much easier. And they often have lower minimum order quantities, or MOQs.
Lower MOQs meaning less cash tied up in inventory initially.
Exactly. Less upfront capital needed. The big trade-off, almost always, is higher unit costs. sometimes significantly higher, maybe 30%, 50% more per unit compared to overseas.
And overseas, primarily Asia, I assume.
Primarily, yes. The big advantage there is usually the lowest possible unit cost, which is obviously crucial for hitting healthy retail profit margins. But it comes with challenges. Much larger MOQs are typical. Longer lead times, just shipping by sea takes weeks. And potentially more complex logistics and quality control management.
So what's a common strategy for startups navigating this?
A very common path is to maybe prototype and produce the first small run, say, the first 500 or 1,000 units domestically. Prove the concept, iron out kinks. Then, once you have traction and need volume, you move production overseas to get that lower unit cost for scale.
Okay. Regardless of location, the vetting process itself needs to be rigorous, you said. What are the key steps to find and secure a reliable partner?
Yeah, you can't just pick one from a website. You need to contact at least 3 potential manufacturers, maybe 5. And you need to provide them with professional, comprehensive requests for, quote, packages, RFQs.
What goes into a professional RFQ?
Everything they need to give you an accurate quote. Your detailed 3D CAD files. Exact material specifications don't just say aluminum, say 6061T6 aluminum, powder-coated matte black to spec XYZ. Your target volume expectations, what's the initial order size, what are your annual projections, and critically, your quality control requirements.
Sending that detailed package helps weed people out.
Immediately. A professional RFQ signals you're serious and organized. It helps weed out the factories that aren't capable or professional enough.
And how do you validate the factory's quality capabilities beyond just their quote?
Look for certifications. ISO 9001 certification is a big one. It confirms they have a documented, robust quality management system in place. If you're looking at suppliers on platforms like Alibaba, well, look for those gold supplier badges or third-party verification reports. But frankly, take those with a grain of salt. Always verify independently.
Verify how? Especially if they're overseas.
If you select an overseas factory, arranging for a third-party audit or inspection is absolutely critical before you commit serious money. You hire firms like SGS, QIMA, or others. They physically go to the factory for you, they audit their processes, inspect the facility, and crucially, they can inspect your first batch of finished goods before they get shipped. It costs money, but it prevents disasters.
Yeah. Cash problems before they cross the ocean. So Decision Gate 8 is passed when?
When you've thoroughly vetted your options, selected a manufacturer you trust, and successfully negotiated and signed a detailed manufacturing agreement. Partner secured.
Okay, partner secured. Now we talk money. Cost modeling and quality planning, this is Decision Gate 9. This is where you finalize the numbers that determine if this business actually makes money.
Exactly, the unit economics. First, you need to account for that big capital expenditure upfront tooling. If you're using injection molding for plastic parts, the NRE non-recurring engineering cost for creating those steel molds could easily be $10,000, $20,000, maybe more depending on complexity.
And you have to spread that cost out.
You have to amortize it, yes. Spread that tooling cost over your expected initial production volume. So if the tool costs $20,000 and you plan to make 10,000 units in the first year, that adds $2 to the cost of every single unit. You can't forget that.
Okay.
Yeah.
What else goes into the final cost?
You need the final landed cost. That includes the per unit manufacturing cost from the factory, the cost of any specialized packaging, the shipping freight cost, which can fluctuate, and any import tariffs or duties if sourcing overseas. That final landed cost is your true cost of goods sold, or COGS.
All right, let's talk about the retail math, Mr. Travis. This is crucial. If your final landed cost, everything included, is, say, $20 per unit, why do you keep saying you need to aim for a retail price of maybe $80 or even $100? That seems like a huge markup, 4x or 5x. Where does all that extra margin go?
It seems like a huge markup, but it's absolutely necessary for survival, especially if you plan to sell through retail channels. Let's break it down.
Okay.
If you sell direct-to-consumer, DTC only, from your own website using something like Shopify, yes, you keep most of that margin, maybe 80% gross margin. Great. But if you sell through Amazon Marketplace, they'll take their cut, usually 15% to 20% or more, depending on the category and fulfillment method.
Right, Amazon fees.
Now, if you want to get into physical retail, those crucial medical supply stores or mobility dealers we talked about, they will typically demand a 50% wholesale discount off your suggested retail price.
50%, wow.
Yes. So if your retail price is $80, they buy it from you for $40. Your landed cost was $20, so you make $20 profit per unit before any of your own operating costs. The retailer makes $40 gross profit. That 4x to 5x markup from your landed cost is essential to cover the retailer's margin, your own overhead, marketing salaries, warehousing, handling potential returns, shipping costs to the retailer, and still leave you with a healthy net profit margin at the end of the day.
Okay, the math makes sense now. That margin gets eaten up quickly. Now, quality control, QC, needs to be locked down before mass production starts. How do you implement a solid QC plan with the factory?
You need a multi-stage QC plan. First, incoming material inspection. Does the raw aluminum or plastic pellet meet the spec you defined? Second, in-process quality checks. Are assembly steps being done correctly? Are dimensions being checked periodically during the production run?
And finally, checking the finished goods.
Right. Final batch inspection before anything ships. This is where AQUAL sampling comes in. Acceptable quality level.
AQUAL. Sounds technical again. Can you simplify AQUAL for someone like Mr. Travis setting up their first factory run?
Sure. AQUAL is basically statistical sampling. It's usually not feasible or cost-effective to inspect every single finished unit, especially for cosmetic things. So AQUAL provides a standardized, statistically valid way to inspect a random sample from a larger batch.
So you pull a few hundred out of thousands.
Exactly. For example, if the factory produces a batch of 10,000 units, the AQUAL standard might tell you to randomly inspect, say, 200 units. Then, based on pre-agreed limits, if you find more than, say, 4 major defects, like something that affects function, or more than, say, 8 minor defects, like a small scratch, within that 200-unit sample, you have the right to reject the entire 10,000 unit batch.
Wow, reject the whole batch based on the sample.
Yes. It keeps the factory accountable. Now, for a safety-critical device like this, Mr. Travis, you might specify an extremely tight AQUAL standard for critical functional aspects. And furthermore, you might even mandate that the factory performs certain critical tests, like that static load test, on every single unit that comes off the line. It adds cost, but for liability reduction on a safety product, it's often a necessary investment.
Okay, so Decision Gate 9 is passed when you've confirmed the unit economics work, the pricing makes sense, and that robust QC plan is formally agreed upon with the manufacturer.
Correct. Profitability model confirmed, quality process locked. Now you're ready to think about actually selling it.
Which brings us to the go-to-market strategy, starting with branding and pricing. The brand identity. It needs to resonate, right?
Oh.
Convey trust, safety, empowerment.
Absolutely critical. The name, the logo, the packaging. It all needs to speak to both the senior user and often their adult children, the caregivers who might be doing the actual purchasing. You want names that evoke ease, reliability, confidence, maybe something like Carees or Safe Step, hypothetically. Avoid anything that sounds too clinical or overly complex.
And the look and feel.
The aesthetic should probably be clean, modern, maybe slightly technical to convey robustness, but definitely not overly medical. That can sometimes carry a stigma people want to avoid. Keep it dignified.
And pricing, we touched on this, needs to align with the value, justify potentially being higher than simpler competitors.
Exactly. If competitors like the Handy Bar are around $30, $40, and your device offers demonstrably superior stability, perhaps better materials, maybe easier attachment, and crucially that crash test validation, then a price point of $50, $75, even up to $100 could be entirely justifiable. Caregivers especially will often pay a premium to mitigate risk and ensure safety for their loved ones.
Okay, now distribution. How do you actually get this product into people's hands? You mentioned a multi-channel approach is vital. Relying on just one channel is too risky.
Far too risky, yes. You need diversification. The first and often most profitable channel is direct-to-consumer, DTC, online. Primarily through your own website, maybe built on Shopify, and also selling on Amazon Marketplace.
What's key for the website, specifically targeting seniors or caregivers?
Optimization is crucial. Your website must be user-friendly for potentially less tech-savvy users or those with visual impairments. That means large, readable text, high-contrast color schemes, simple navigation, very clear product photos and videos showing how it works, and, very importantly, a prominent, easy-to-find phone number for customer support. Older demographics often still prefer calling someone.
And online advertising. Who do you target?
While the end user is the senior, your digital advertising Facebook ads, Google ads should often primarily target the caregivers. Typically, they're adult children, maybe in the 40 to 60 age range. They're often the ones researching solutions and making the purchase.
Okay, DTC online is channel 1. What about specialized retail?
Specialty retail is potentially huge for this product, Mr. Travis. Think medical supply stores, durable medical equipment, DME providers, mobility dealers who sell wheelchairs and scooters. These places have established trust with your core audience.
Right, they're already serving that market.
Exactly. Now, they will expect that standard 50% wholesale discount off your retail price, but they provide valuable services, expert advice, sometimes installation help, handling returns locally. Getting placement in these stores is a major credibility boost. You might also explore catalog retailers that target affluent seniors.
Okay, and the third channel you mentioned. The one that sounded difficult but potentially very rewarding. Insurance and medical.
Yes, this is the high barrier, high reward channel. It requires a significant investment of time and possibly resources. You'd need to investigate the complex, often bureaucratic path to getting your device classified as durable medical equipment, DME, by Medicare, or obtaining a specific HCPCS code.
HCPCS code.
Healthcare Common Procedure Coding System. It's the code doctors and suppliers use to bill insurance. Getting one isn't easy. It means navigating governmental regulatory hurdles, providing extensive clinical justification and documentation. But if you achieve it, it potentially unlocks insurance reimbursement.
Meaning customers might get it covered.
Potentially, yes, through programs like the VA for veterans or maybe state-level Medicaid programs for disabled drivers or seniors meeting certain criteria. This dramatically expands your potential market volume and significantly lowers the price sensitivity for the end user if insurance picks up some or all of the cost. It's a long game, but worth exploring down the line.
Wow, okay. Regardless of the channel, you emphasized educational marketing. Why is content so important here?
Because there's likely an awareness gap. People might not even know solutions like yours exist. Content is key to bridging that gap. You need to create helpful, informative guides, blog posts, maybe short videos, things like 5 tips for safe car transfers or how to choose the right mobility aid for your needs.
Position the brand as an expert.
Exactly. Position your brand as a trusted authority on senior mobility and safety, not just a product seller. This pull marketing approach builds trust, answers questions potential customers have, and draws them to your solution organically. It's vital for a safety-critical product where trust is paramount.
And finally, wrapping up phase 3, protecting the business itself. Liability.
Absolutely non-negotiable. You must secure product liability insurance immediately before selling your first unit. A typical policy offering $1 million to $2 million in coverage might run somewhere between $500 and $1,200 per year initially, depending on your projected sales volume and the inherent risk of the product. Get multiple quotes.
And customer support policies.
You need clear, generous customer support protocols. A straightforward 30-day return policy builds confidence, and offer dedicated support via both phone and email. As we said, many seniors prefer calling. Excellent, accessible customer service reinforces the trust required when someone is buying a device designed explicitly to prevent injury. All right, phase 4, we're now moving into the most strategically important part of the blueprint, Mr. Travis. This involves pursuing those potentially game-changing automotive partnerships and consciously planning for your long-term exit. This isn't something you do after direct sales. It's a parallel strategy you should be thinking about almost from the start.
Okay, so the objective here is targeting automotive OEMs, the car manufacturers themselves, and also the Tier 1 suppliers, the big companies that make major components like seats for the OEMs.
Exactly. These partnerships offer potential for massive scale and immediate widespread credibility that's hard to achieve just through direct sales.
Which OEMs or Tier 1s should you focus on?
Strategically, you should probably target OEMs that already show some focus on accessibility or cater to demographics likely needing assistance. Think about manufacturers with popular minivan lines or larger SUVs often favored by older drivers, maybe Ford, Toyota, Honda, Subaru perhaps. Or look at the major seating suppliers like Adient, Lear, Magna Seating. They're always looking for innovations to offer their OEM customers.
And how do you even get your foot in the door with these huge companies?
It requires a polished, highly technical approach, not a consumer sales pitch. You need to leverage your filed patent application. That patent pending status is key. Attending major industry trade shows like CES in Las Vegas or SEMA, the aftermarket show, can be good places to connect with innovation scouts or business development folks from these companies. But your pitch materials when you get the meeting have to be absolutely exceptional.
Exceptional how? What are the non-negotiables they need to see in that pitch? They're not just buying a handle, right?
Definitely not. They demand detailed technical briefings. You must be prepared to present your safety validation data, specifically mentioning your compliance with FMVSS 302 for flammability. And critically, highlighting your success in passing that rigorous 20 green crash safety testing we discussed.
That crash test really matters to them.
It's huge. It instantly tells them your product isn't just some flimsy gadget, it meets their internal culture of safety and rigor. You also need a rock-solid business case. Show them data on the size and spending power of the 55-plus demographic. Explain how offering your device as an official accessory helps them attract and retain these valuable, often brand-loyal customers. Frame it as a solution for them.
Okay, let's say they show interest. What kind of deal structures should you be prepared to discuss?
Yeah.
Licensing.
Licensing is very common, yes. You need to be ready to discuss potential structures. Maybe proposing an initial pilot program first, like let's equip X number of vehicles in a test fleet, then be prepared to discuss licensing terms if the pilot succeeds.
What's a typical royalty rate in this kind of deal?
For consumer hardware or automotive accessories, the standard royalty rate often falls somewhere in the range of 3% to 5% of the partner's net sales revenue generated by your product. You also need to clearly define who owns any future IP improvements made during the partnership.
And the ultimate goal here, Mr. Travis.
The ultimate goal is securing an official accessory partnership, where your device becomes a recognized, maybe even co-branded add-on that customers can order right from the dealership when they buy the car, or get installed later through the dealer network. Think of successful examples where specialized tech becomes an official OEM accessory, like maybe certain high-end bike racks or cargo systems, or that true assistive tech example with Hyundai Mobis. That kind of deal instantly confirms your product's legitimacy and provides massive scale potential.
Okay. Running parallel to pursuing those big fish, you mentioned needing to decide on the core operating model for the business itself, make and sell versus license.
Right. This is a fundamental strategic choice, Mr. Travis. You need to decide, are you building a company that primarily manufactures and sells its own product? Or are you aiming to be primarily an IP holding company that licenses its technology out to others?
Let's break down the pros and cons of each. Make and sell first.
Okay. The manufacture and sell model means you retain maximum control. Control over the branding, the pricing strategy, the product quality, the customer experience. You also typically keep the highest potential profit margin per unit sold. And importantly, you're building a tangible operational business asset that could potentially be sold later.
But the downside?
It requires significantly more capital investment upfront for inventory, warehousing, logistics. It requires more operational effort managing manufacturing, supply chains, marketing, sales, customer service. You need a dedicated team. It's more complex to run day to day.
Okay. And the license model?
The license model is generally lower risk and requires much less capital. You essentially gain an instant passive income stream through the royalty payments from your licensee. And you get instant scalability because your partner uses their already established manufacturing, distribution, and marketing channels.
Sounds easier. What's the catch?
The catch is you surrender almost all control over branding, pricing, quality, beyond what's in the contract, how it's marketed, and your potential earning per unit is significantly lower, that 3-5% royalty, versus maybe a 40-60% gross margin if you sell it yourself.
So what's the recommended approach for someone starting out like Mr. Travis?
Our recommendation is often a hybrid approach, at least initially. Self-manufacture and sell directly first, even if it's on a smaller scale. You need to prove the market demand, establish your brand identity, refine your operations, get real customer feedback.
Build leverage.
Exactly. That initial traction, that proof of concept in the real market, gives you crucial leverage if and when you decide to negotiate a potentially lucrative licensing deal with a major OEM or a large distributor later on. You'll command much better terms, a higher royalty rate, better conditions if you can show them you've already built something successful on your own. Keep the licensing option open, maybe for specific channels or international territories, but build the core business first.
Okay, that makes sense. Build it first, then license selectively. Now, underpinning all of this is rigorous financial planning and setting clear milestones.
Absolutely essential. You need a detailed development budget, Mr. Travis, showing your projected cash flow needs for every single phase we've discussed. How much for Phase 1 research? Phase 2 prototyping and testing? What about the NRE for tooling in Phase 3? And critically, the cash needed for that first big inventory order, which, based on our earlier math, could easily be $15,000, $20,000 or more just for the first batch of units.
Need to know how much money you need and when.
Precisely. And just as important, you must establish a clear break-even analysis. This is crucial for managing growth and ensuring financial sustainability. Break-even, meaning calculating how many units you need to sell. Exactly. Calculate your total fixed operating costs per year, things like insurance, software subscriptions, maybe a small salary or contractor fees, basic marketing spend. Let's say that's $50,000 per year. Then determine your net profit per unit after COCO-GS and any channel discounts. If that's, say, $30 per unit, you divide the fixed cost by the per unit profit. $50,000 divided by $30 means you need to sell approximately 1,667 units in that year just to cover your fixed costs and break even.
Knowing that number helps guide decisions.
Tremendously. It tells you the minimum sales velocity you need to survive. It helps you set realistic sales targets. And it helps you define clear milestones for expansion. For example, maybe you set triggers like, we aim to be cash flow positive by month 18, or if we hit $6 revenue per quarter, we trigger the budget to hire a part-time operations manager. These milestones keep spending aligned with actual progress.
Okay. Finally, let's talk about managing risks and thinking about the end game. Exit readiness.
Right. While risk mitigation should be ongoing throughout the process, addressing technical risks through testing, supply chain risks by maybe identifying a backup manufacturer, dual sourcing, market risks by diversifying distribution channels. The ultimate goal for many entrepreneurs, Mr. Travis, is maximizing the value of the business for a strategic acquisition down the road, maybe in a 5 to 7 year time frame.
Okay. So how do you prepare for that potential exit? What makes the company attractive to a buyer?
This is where the exit checklist becomes your strategic guide. Potential acquirers, whether it's a large established mobility aid company looking to expand their portfolio, or maybe a tier 1 automotive supplier wanting your technology, they're essentially buying two things: predictable revenue streams and de-risked operations.
De-risked operations, meaning easy to take over.
Exactly. To drive the highest possible valuation for your company, you need to ensure several things are in place before you even think about selling. First, granted IP. Actually issued patents, not just pending applications. They carry much more weight. Second, extremely clean, well-documented financials. Auditable books, absolutely zero commingling of personal and business expenses. It's a huge red flag for buyers.
Clean books. Got it. What else?
A stable, well-documented, and transferable supply chain, meaning the buyer can be confident that if they acquire the company, the engine will keep running smoothly. Contracts with suppliers are clear, quality processes are documented, maybe you even have that backup supplier relationship established.
So it's not just about the sales numbers.
Sales numbers matter, of course. But these operational details, the granted IP, the clean financials, the stable supply chain, combined with the proof of concept validated by all that rigorous safety testing and successful initial market traction, that's what elevates your company's valuation beyond just a simple multiple of revenue or profit. It positions you as a well-managed, low-risk, highly attractive strategic asset for the right buyer.
That really paints the full picture. From idea to exit.
That completes the blueprint, Mr. Travis. As you can see, it's an integrated roadmap. It provides you with actionable steps for every stage, from making sure your innovation is solving a real problem and is legally protected, all the way through to establishing robust, scalable production and distribution, and finally, plotting your course towards a potentially high-value exit strategy.
It's incredibly comprehensive. And now, Mr. Travis, a final and very important word regarding the support you have from Rocket 30 throughout this journey. As we close out this detailed blueprint discussion, Tony personally specifically requested that we convey this message. Please reach out to him directly at any time during this entire process. If you have any questions, big or small, if you need guidance, whatever the complexity, he wants you to call him.
And we really cannot overstate how significant that is. Mr. Travis, you must have built a truly special rapport with Tony, because, quite frankly, he very rarely offers this level of direct, personal accessibility and ongoing involvement to ventures, especially at this relatively early stage. Consider this a tremendous asset.
It really is. That level of direct CEO support, coupled with this incredibly detailed, custom start-to-finish blueprint we've outlined today, well, means you are in a uniquely fortunate and advantageous position, Mr. Travis.
Absolutely. We sincerely encourage you to make the absolute most of this unique opportunity. To take this blueprint, leverage the support available, and bring your important vision, this vital solution for improving senior and disabled mobility, fully to life. You have the plan, and you have the backing of Rocket 30 and Tony's personal guidance.